Welcome back everyone to part 4 of our series. In the previous videos, we made great progress. We successfully installed 10 kW AM transmitter, conducted tests, and explored the main modules it contains. In today's video, I will guide you through the process of operating a 10 kW AM transmitter step by step. You will learn everything you need to know to operate it correctly. Remember to stay connected with our channel, like our videos, and share them with others. Let's get started. Let's start by exploring the functionalities of the control panel. Familiarizing yourself with the control panel functions and understanding how to interpret diode data is crucial for engineers and technicians working with an AM station.
Control panel introduction.
We have 3 main sections on the control panel in the 10 kW AM transmitter, which are number 1, monitoring dashboard, number 2, tuning control panel, number 3, status lights panel. The top section is the monitoring dashboard, consisting of 3 screens. The first screen is the voltage display dial. It monitors the voltage of the specific module. The second screen is the current display dial. It monitors the current of the specific module. The last screen is the power display dial. It monitors the output power of the transmitter. The second section is the tuning control panel, consisting of 5 groups of buttons from left to right. The first group is the module shifting. This is the button group for shifting important built-in module voltages of the transmitter. The second group is the power level. This is the button group that controls the default power level of the transmitter, with 3 default modes. Low mode equivalent to 1 kW, medium mode equivalent to 5 kW, and high mode equivalent to 10 kW. The third group is the power adjustment. There are 2 buttons, higher and lower, for fine-tuning the real-time output power based on the display panel area. The fourth group is the one-button switch. This is a single button for switching the transmitter power supply on or off. The fifth group is the forward or reverse power selection. This is a button for selecting forward or reverse power. The final section is the status lights panel. It includes working status indicators, monitoring areas, and buttons for several modules. Green indicator lines simplify normal working voltage for the corresponding modules, while red lines indicate a faulty working voltage that requires prompt attention. The modules are as follows. Exciter, it indicates the working status of the transmitter excitation module, and buffer, it indicates the working status of the transmitter buffer module, and driver, it indicates the working status of the transmitter RF driver, and PA, it indicates the working status of the transmitter power amplifier module. In addition to the above-mentioned important modules, there are also auxiliary monitoring modules that function independently from other modules. These include the first one, controller. It prompts the operator to toggle the transmitter and select between local control, which means on-site control, or remote control, for example, RS-232. And interlock indicates whether the transmitter is properly connected to the external devices such as dominant, and built-in devices such as fans and doors. And overload, it indicates whether the main voltage of the transmitter is overloaded. And VSWR, it indicates whether the transmitter VSWR, also known as voltage standing wave ratio, is within normal parameters. Now that we have explored the different functions of the control panel, it becomes evident how crucial it is to have a comprehensive understanding of these features. In the next section, we will delve into the step-by-step process of properly troubleshooting the 10 kW AM transmitter, covering all the important aspects in detail. Step number 1. Verification of voltage levels for key components. To ensure a safe startup process, begin by connecting the high voltage power supply to the transmitter, followed by the low voltage power supply. However, refrain from turning on the power amplifier at this stage. This step allows us to verify if the indicator lights on the control panel detect normal voltage readings for each module when the low voltage power is connected. Next, direct your attention to the controlled area on the control panel. This area consists of 8 indicators and a yellow button positioned on the far left side. The purpose of this section is to access the voltage status of various transmitter components when it is not powered on. The yellow button enables switching between different options. Within this control area, you will find 4 options, with each option containing 2 distinct detection items. These detection items are crucial for monitoring and ensuring the proper functioning of the transmitter. The left side, from bottom to top, there are 3-volt net node, antenna node, and RF drive. It is important to note that the following 4 indicators should ideally display a reading of 0 volt to be considered within normal parameters. And the right side, from bottom to top, there are PA volt, net node, antenna node, and RF drive. Among these indicators, it is important to pay attention to the PA volt and net node indexes. Look at the first row of numbers where a reading of 8 volts indicates normal functioning. Similarly, for the RF drive and antenna node indexes, check the third row of numbers on the meter, where a reading of 22 volt is considered normal. In case you notice a slight deviation in the voltage, there's no need to worry, as this is within the expected range. Step number 2, main modules troubleshooting. The second step involves troubleshooting the indicator lights of the main modules. To identify the problem, we first need to locate the circuit board associated with each main module indicator light in the transmitter. Open the protective board of the main module. In the lower right corner, you will find the exciter circuit board, corresponding to the exciter indicator light. On the left side of the top layer, locate 2 circuit boards. The one on the first layer is the level RF driver board associated with the driver indicator light. Adjacent to the level RF driver board are 3 secondary RF driver boards on the right, corresponding to the driver indicator light. On the left side of the second layer, you will find the buffer amplifier board, which corresponds to the buffer indicator light. Finally, the circuit board with the largest number is the power amplifier board, associated with the PA indicator light. Exciter troubleshooting. When the power supply of the exciter module is disconnected, it can result in the exciter not working properly. This is indicated by the exciter indicator light on the monitoring panel turning red. This light serves as a visual warning, alerting the operator to issue and indicating the need to address the exciter troubleshooting. Ensuring the proper functioning of the exciter module is crucial for maintaining the overall performance and reliability of the AM transmitter. Buffer troubleshooting. The buffer module is responsible for boosting the signal generated by the exciter and preparing it for further amplification. In case the buffer amplifier board becomes loose or is pulled out, the monitoring panel's buffer indicator light will turn red. This serves as a visual indication that the buffer module is not functioning properly and prompts the operator to check for any loose connections or issues with the board. Driver troubleshooting. The RF driver module is a crucial component in a 10 kW AM transmitter that plays a significant role in amplifying and controlling the radio frequency signal before it reaches the power amplifier stage. If the driver RF board becomes loose or is pulled out, the monitoring panel's driver indicator light will turn red as an indication that the RF driver module is not functioning properly. This serves as a visual reminder to the operator to check for any loose connection or issues with the board. The RF driver module's importance lies in the role in signal amplification, control, and preservation of the signal quality. PA module troubleshooting. The PA module takes the RF signal from the RF driver or exciter module and significantly boosts its power to the desired level for transmitting over long distances. In the event that the power amplifier board becomes loose or is pulled out, the monitoring panel's PA interlock indicator light will turn red. This serves as a visual alert, indicating that the power amplifier board is not properly connected or functioning correctly. It prompts operators to check for any loose connection or issues that may affect the performance of the power amplifier. In this particular case, the transmitter consists of 48 power amplifier boards, each forming an integral part that cannot be separated. Consequently, if any of the power amplifier boards are disconnected prior to startup, it will prevent the adjustment of the transmitter's output power. In other scenarios, if a power amplifier board becomes faulty, the transmitter will still operate, but the PA interlock indicator light will change from green to red. However, the transmitter's power output will decrease. It is crucial to note that the attempting to unplug a damaged power amplifier board while the transmitter is operational can cause irreversible damage. To address this issue correctly, it is important to first turn off the transmitter's power. Then, identify the faulty power amplifier board, disconnect it, and replace it with a new one. Afterward, power on the transmitter and conduct proper testing. It is worth emphasizing that it is highly recommended not to unplug any of the 48 power amplifier boards before turning on the transmitter. Doing so poses significant risks and can be extremely hazardous for the transmitter operation. In this demonstration, we simulated the process of damaging one of the power amplifier boards by pulling out its fuse. Each power amplifier board's fuse is designed to withstand a voltage of 5 volts. To ensure preparedness for unforeseen situations, we have provided our Filipino customers with a pack of spare fuses for emergency use. Now, let's proceed to plug the power amplifier board back into its original position. As we do so, we can observe that the PA indicator light has turned green once again, indicating that the power amplifier board is functioning properly. Step number 3. Audio processing sections troubleshooting. Alongside the PA indicator lights, the panel also includes 4 small area monitoring indicators. As mentioned previously, if any of the 48 power amplifier boards in the transmitter are damaged or loose, the PA interlock indicator light will turn red. Apart from the DC power indicator light, which indicates the voltage status of the DC power supply, the remaining 2 small area monitoring indicators signify the voltage status during audio signal processing before entering the PA module. The audio input troubleshooting. In this 10 kW AM transmitter, the audio input board has a pair of fuses corresponding to positive 50 watts and negative 50 watts, respectively. If one of these fuses is removed while the transmitter is powered on, several indicators on the monitoring panel will reflect change. Specifically, the voltage indicator light of the audio input board will transition from green to red, and the transmitter will cease to generate any output power. Additionally, the indicator light of the power amplifier section will also shift from green to red. This occurs because the audio input board loses its power supply. The A/D converter troubleshooting. The role of the A/D audio converter is to transfer the incoming analog audio signal into a digital format. Now let's take a closer look at the 4 indicator lights on the display board of the A/D converter. These indicators are labeled as positive 50 volts, negative 50 watts, and positive 5 volts, and conversion error. If any of the fuses associated with these voltage supplies are faulty, such as being blown or missing, there will be no output power when the transmitter is powered on in this condition. Step number 4. Troubleshooting monitor module. Some customers have raised questions about which module in the transmitter can be connected to a detection instrument to measure RF indicators, such as amplitude modulation and frequency. To address this, let's open the front panel of the cabinet. At the top layer, there is a circuit board connected to the feeder, referred to as the sampling board. Its purpose is to establish a connection with RF detection equipment. Through this connection, we can measure RF indicators, including modulation amplitude and frequency. On the monitoring panel, there are 2 indicator lights labeled positive 5 volts and negative 5 volts. The sampling board itself is equipped with 2 fuses. If either of these fuses is missing or damaged, the corresponding indicator light will turn red. These lights serve to monitor the voltage of the sampling board and ensure it is within the normal range. Step number 5. Troubleshooting VSWR. If the antenna's VSWR becomes too high, it will have an impact on the transmitter's monitoring panel. On the front panel monitoring area, there are 2 modules called VSWR and Monitor that specifically monitor the status of the antenna's VSWR. In normal conditions, when the VSWR reaches a level of 3 or 4, it is considered normal. However, if the VSWR exceeds this range, either higher or lower, the net VSWR indicator light on the monitor module will turn red. This indicates that the antenna's VSWR has exceeded to the acceptable limit and is too high. In a scenario where the transmitter is operating normally, if we intentionally short-circuit the connection between the antenna and the transmitter and switch to a low power mode for testing, the net VSWR indicator light on the monitoring module will also turn red. This serves as a prompt that the antenna's VSWR is excessively high. Step number 6. Interlock module troubleshooting. By keeping a close eye on the lighting status of the indicator light in the interlock area, operators can promptly identify and address any potential issues related to external connections, the cabinet door, and fan operation. EXT indicator troubleshooting. Let's begin with the EXT indicator. We have the EXT indicator, which stands for exterior, referring to the external devices connected to the transmitter. The EXT external device indicator light serves the purpose of detecting the presence of the ground signal and indicating the normal functioning of the equipment connected to the transmitter. For instance, if the transmitter is connected to a load, such as a dummy load, and it becomes overheated or is not switched on, a signal will be sent to the transmitter. As a result, the EXT indicator light will turn red, indicating an alarm situation. In the case of a transmitter equipped with an N+1 main and backup system, the EXT indicator light serves an additional purpose. When the backup unit is turned on or off, the EXT indicator light will respectively turn green or red. This serves as a reminder to the operator regarding the status of the backup unit.
Fan indicator light troubleshooting.
The fan work indicator light is responsible for indicating the normal operation of the fan integrated into the transmitter. To test the status of the fan indicator light, we can simulate a fault by removing the fan fuse and powering on the transmitter. However, it is crucial to note that it is extremely dangerous to operate the transmitter without a functioning fan. In such cases, the heat generated cannot be adequately dissipated, potentially leading to damage. To mitigate the risk, we first need to turn off the PA module as a precautionary measure. Locate the PA switch and lift it up to deactivate the PA module. Afterward, we can start the transmitter again. If the fan module is not functioning properly or has been damaged, the fan indicator light will turn red. This indicates the need to check the fan for any issues, such as a blown fuse, and consider if a replacement fan is necessary. Door on and off indicator light troubleshooting. This light fault detection is responsible for prompting the operator to ensure that all cabinet doors of the transmitter are properly closed. There are 5 checkpoints to consider. The cabinet door of the built-in ATU space on the front panel. The second layer cabinet door that protects the power amplifier module on the front panel. The cabinet door of the front panel protection transformer module. The cabinet door of the back panel protection filter module. And the cabinet door of the back panel protection built-in ATU module. What happens if a door is opened while the transmitter is running? The transmitter will not shut down completely, but will turn off transmitting power.
Open the door.
By default, the operation of the machine is suspended when any door is opened. To resume operation, the operator needs to first close the panel door and then click the turn off button to restart and continue running the device. Step number 7. Transmitter overload monitoring and shutdown. The overload module continuously monitors the RF output of the amplifiers, alerting the operator through prompts or indicator lights if any overload or issues are detected. When any of these values exceed the predetermined threshold, protective measures are activated. The main power module troubleshooting. Within the overload monitoring area, 3 indicator lights are provided under the main power section. These lights represent voltage, current, and 3-phase AC status. Under normal conditions, when the transmitter is operating within safe limits, these indicator lights remain green. However, in the event that any of the monitored values exceed their predetermined thresholds, an automatic response is initiated. For instance, if the voltage surpasses 250 volts, the current exceeds 90 amps, or if any of these 3 phases of the AC power supply is absent, the corresponding indicator light will immediately turn red. Alongside this visual warning, the transmitter will promptly initiate an automatic shutdown process. The RF driver module troubleshooting. In the event that multiple power amplifier boards within an AM transmitter become damaged, the most likely cause can be attributed to voltage overload. To monitor the voltage status of the power amplifier board, the overload monitoring area includes 2 indicators labeled as under and over under the driver section. These indicators reflect the driving voltage condition of the power amplifier board. In the case of a 10 kW AM transmitter equipped with 48 small power amplifier boards, it is crucial to maintain the driving voltage at the standard level of 22 volts. Deviation from this standard voltage, either higher or lower, can lead to extensive burnout across all power amplifier boards. To mitigate such risks, an automatic voltage regulator is installed. Once the driving voltage falls below or exceeds the normal ground state, the regulator actively prevents adjustment, triggering an automatic shutdown to safeguard the power amplifier boards. Step number 8. Power on and voltage check for key components. Ensure that all components are in the correct position before turning on the transmitter. Focus on the power level section in the tuning control panel. This 10 kW AM transmitter has 3 default output power modes, allowing engineers to fine-tune the power using higher and lower options. The available power modes are low, medium, and high, corresponding to power levels of 1 kW, 5 kW, and 10 kW respectively. Before selecting a mode, ensure that you switch the yellow button next to it from instance to reflect. This change allows you to observe the forward power instead of the reverse power. Failure to do so will result in the power monitoring screen's pointer not moving. Additionally, the second circuit board next to the door contains 3 batteries that store the transmitter's power. These batteries should be replaced every 2 to 3 months, or if the transmitter fails to retain power, which should be rare. Changing the battery does not affect normal operation. If, for example, you select high power mode, but the pointer on the power monitoring screen remains unchanged, it is likely that the battery controlling the automatic adjustment to the default power is depleted, and you need to replace it. Note that even a high power mode is selected, the transmitter's transmitting power remains below 11 kW. It is recommended to fine-tune the transmitting power to approximately 10 kW to protect the transmitting system. After ensuring that the power is turned on, check whether the power amplifier PA voltage is 220 volts in high power 10 kW mode. Click the yellow button on the left and select PA volts. The indicator light will illuminate to confirm your selection. Illuminate. After ensuring the power is turned on, check whether the power amplifier PA voltage is 220 volts in high power 10 kW mode. Click the yellow button on the left and select PA volt. The indicator light will illuminate to confirm your selection. Click high in the power level area to set the output power to 10 kW. Be aware that external factors may cause fluctuations in the voltage of the PA module within a 10 volts range, but it generally stays below 255 volts. If the voltage exceeds this limit, the transmitter will automatically shut down. Simultaneously, the volt TS indicator light in the overload monitoring area will change from green to red, indicating an overloaded transmitter voltage.
And the transmitter will down.
Down automatically.
Yeah, automatically.
Next, measure the impedance from the output of the power synthesis transformer to the ground wire connected to the built-in ATU of the transmitter. There are 2 measurements to consider: antenna now and network now. Both should read 0 volts. In certain cases, the voltage of the antenna now may temporarily increase to a non-zero value. This occurs when the power of the transmitter is turned off during testing, resulting in a decrease in the internal temperature of the transmitter. It usually takes about 10 minutes for the value to recover and return to 0 volts. So we have reached the end of our journey exploring the installation and operation of a 10 kW AM graphic station in Cabanatuan, Philippines. In part 1, we successfully set up the 10 kW AM transmitter and performed a power on test. In part 2, we connected the AM mast tower to the AM antenna unit and conducted AM impedance matching and aging tests. Part 3 introduced various components of the transmitter. Now, in part 4, we have completed the basic troubleshooting of the indicator light for the 10 kW AM transmitter, ensuring the system's smooth operation for an extended period. Make sure to check out the video description for a comprehensive summary of the entire project and all the relevant information you might need. We hope you find it informative and enjoyable. Stay tuned for the future content. as we have more exciting projects coming your way. Bye bye!